This project is brought to you through the help of the UNC Charlotte Senior Design Program and is intended for use by Husker Incorporated. Husker Incorporated is a global leader in the geotextiles industry. At their Shelby, North Carolina facility, one of their key products is manufactured by felting three materials into a composite fabric. The needling machinery was never intended to handle this variety of fabrics, so a makeshift feeding system was later introduced, which makes material changeovers resource intensive and allows the material feed to drift, diminishing product quality and increasing waste. The goal of this project was to design and manufacture a material handling system that would reduce the resources necessary for a changeover, reduce variation in product quality, and improve worker safety. The project's 5 performance specifications focused on reducing the time, labor, and number of workers necessary to perform a material changeover, while also reducing material feed drift to improve product quality and reduce the number of workers necessary to operate the machine. The team has successfully manufactured a 100% complete prototype, which was then transported to the Shelby facility, installed, tested on the product line, and handed over to Husker along with an installation and owner's manual. The design is intended for use on the product's absorbent layer, which requires changeovers most frequently and experiences the most drifting. The design consists of 3 subsystems: the frame, the carriage, and the track. The frame consists of 2-inch by 5-inch welded steel tubes, multi-directional and rigid caster wheels, and a chest-height handle to easily maneuver the absorbent jack. The carriage consists of a hydraulic jack which lifts the absorbent roll to operational height along 1.25-inch linear shafts and bearings. The absorbent pole rests upon the carriage plate, which can be locked into place with a safety chain to relieve the tension from the jack during operation. A custom-built quick-release collar easily secures the absorbent to the carpet pole. In the track subsystem, 2 V-groove wheels are mounted to the side of the frame which engage with a V-groove track. While the track keeps the jack aligned with the needling machine, a plunger pin keeps the jack from moving along the track. The positioning screw provides fine adjustment to the jack relative to the feed system. The 3 subsystems combined result in a prototype that lifts, transports, aligns, and secures the absorbent rolls during composite fabric production. Testing consisted of filming and timing a changeover both with and without the prototype, as well as running the machine for 2 minutes to observe drifting. The result was that the prototype reduces changeover time by 37%, reduces drift by 75%, reduces instances workers must lift materials by 100%, reduces workers necessary for a changeover from 3 to 1, and eliminates the need for a worker to manage drifting while the machine is in production. In conclusion, the project was completed on time and within budget, and the prototype exceeded all specifications agreed upon by Husker Incorporated. Finally, we want to share our appreciation for the involvement of Husker Incorporated, specifically Mr. Louis Motu, and for the support of the Senior Design Program, specifically Dr. Jerry Dahlberg. Thank you for making this project possible.